Our planet, a fragile blue marble suspended in the vastness of space, has always been a stage for human conflict. For decades, the ultimate threat has been the specter of nuclear annihilation, held in a delicate, terrifying balance. Today, that balance is being tested. We are entering a new era of weaponry, one defined by incredible speed and intelligence. In response, the United States is looking not to the land or the sea, but to the silent vacuum above our heads. The Pentagon is embarking on an ambitious journey to build a defensive shield in space, a project that could fundamentally reshape global security and our relationship with the final frontier. It's an idea born from necessity, driven by the rapid evolution of threats that can cross continents in mere minutes. This grand endeavor, often referred to as the Golden Dome or SHIELD initiative, represents a monumental shift in strategic thinking. For most of the space age, the cosmos was a place for observation, communication, and inspiration. Satellites looked down, they listened, and they connected us. But now, the US Space Force is actively pursuing a future where space is not just a passive high ground for surveillance, but an active arena for defense. The goal is to create a layered network of sentinels and guardians orbiting the Earth, ready to act at a moment's notice. This isn't just about placing a few new satellites in orbit. It's about building an integrated, responsive architecture in the sky. The primary motivation for this cosmic shield is the alarming progress made by nations like China, Russia, and North Korea. These countries are no longer just building traditional ballistic missiles, which follow predictable arching paths like a thrown ball. They are pioneering a new class of hypersonic weapons. Imagine a missile that doesn't just fly fast, but can also maneuver unpredictably, skimming the upper atmosphere at more than 5 times the speed of sound. These weapons are designed to evade existing ground-based radar and interceptor systems, presenting a challenge that today's defenses were simply not built to handle. The 2021 test by China of a globe-circling hypersonic vehicle sent a clear signal: the old rules of missile defense are becoming obsolete. This new reality has forced a profound strategic recalculation in Washington. President Trump's executive order in January 2025 set the stage, calling for a comprehensive shield capable of defending against all types of missile threats, from any origin. The subsequent actions, like the Space Force's request for prototype proposal in October 2025, have turned this vision into a tangible program. The directive is clear. America must develop the capability to neutralize threats, not just as they near their targets, but at the very beginning of their journey. The ultimate goal is to create a defense so robust and reliable that it deters an attack from ever being launched in the first place, preserving peace through strength projected from the heavens. So, how would this celestial shield actually work? The concept is both elegant and incredibly complex, relying on a layered system of technologies working in perfect harmony. The first and most critical layer is detection. The plan involves deploying a constellation of advanced satellites, like the Hypersonic and Ballistic Tracking Space Sensor, or HBTSS, which act as the system's eyes. These sensors are designed to constantly scan the Earth's surface for the intense heat signature of a missile launch. By positioning these sensors in space, they can see over the horizon, detecting a launch from anywhere on the globe almost instantly. They are the tripwire, the silent watchman whose only job is to see the fire and sound the alarm. Once a threat is detected, the next step is to track it. This is where the system's intelligence comes into play. The HBTSS and other planned sensor satellites don't just see a hotspot, they follow its trajectory with extreme precision. They can calculate its speed, its direction, and crucially, predict its path. This data is relayed in real time through the network, creating a complete digital picture of the threat as it ascends. This tracking capability is vital, especially against new hypersonic glide vehicles that can change course mid-flight. The system must be smart enough to anticipate these maneuvers, ensuring that the defenders are always one step ahead of the weapon they are pursuing. The heart of the system is the Space-Based Interceptor, or SBI. These are the system's defenders, essentially rockets, or kinetic interceptors, housed in their own orbiting satellites. When the sensor network identifies and tracks a hostile missile in its initial boost phase, while it is still climbing through the atmosphere and burning its engine, the command is given. The nearest interceptor satellite would release its payload. This interceptor, a relatively small and agile vehicle, would then use its own thrusters to steer itself directly into the path of the ascending missile. The goal is not to create a massive explosion, but to achieve a direct collision, a hit to kill, using nothing but the immense kinetic energy of the impact to destroy the missile. The beauty of this boost phase interception is that it neutralizes the threat at its most vulnerable moment. An ascending missile is a large, hot, and relatively slow-moving target, and destroying it over the attacker's own territory means its warhead and any potential decoys never have a chance to be deployed. This is the game-changing promise of the Golden Dome. It's an attempt to move the battle from our doorstep to the attackers, intercepting the arrow just as it leaves the archer's bow. By combining persistent surveillance from space with a rapid response network of orbiting interceptors, the system aims to create a nearly impenetrable defense against the world's most dangerous weapons. The idea of stopping missiles from space might sound like something from a science fiction movie, and in many ways, its roots lie in a real-world project that was often compared to one. In the 1980s, President Ronald Reagan proposed the Strategic Defense Initiative, or SDI, famously nicknamed Star Wars by its critics. The vision was a futuristic shield, involving space-based lasers and particle beams, to render nuclear missiles impotent and obsolete. At the time, the concept was visionary but ultimately crushed by the immense technological and financial hurdles. The computers weren't powerful enough, the sensors weren't sensitive enough, and the cost of launching anything into orbit was astronomically high. Fast forward to today, and the landscape has transformed in ways that the architects of SDI could only dream of. The single greatest enabler is the dramatic reduction in launch costs. In the 1980s, sending 1 kilogram of payload into space cost around $30,000. Today, thanks to reusable rockets pioneered by companies like SpaceX, that cost has plummeted to around $1,500 per kilogram, and is projected to fall even further. This economic revolution makes the idea of deploying a large constellation of hundreds or even 1,000 interceptor satellites financially plausible for the first time in history. What was once a budget-breaking fantasy is now a line item in a defense contract. Alongside cheaper access to space, we've seen an explosion in the miniaturization and mass production of satellite technology. Companies are now capable of building multiple satellites per day on assembly lines, a stark contrast to the bespoke, handcrafted approach of the past. Furthermore, the computing power that once required a room-sized mainframe now fits on a microchip. This allows for incredibly sophisticated sensors, processors, and communication systems to be packed into smaller, more affordable satellites. These advancements mean that a modern space-based defense network can be more resilient, more capable, and deployed far more quickly than its 1980s predecessor. While today's Golden Dome shares the same fundamental goal as Star Wars, intercepting missiles before they reach their target, its approach is more pragmatic. Instead of exotic, directed energy weapons, the current plan focuses on proven hit-to-kill kinetic interceptors, which are essentially just very smart, very fast projectiles. The system relies on a distributed network of many smaller, cheaper satellites, rather than a few large, exquisite, and vulnerable ones. This makes the system more scalable and harder to defeat. In essence, while the dream is the same, the tools of today have finally caught up with the ambition of yesterday, turning a futuristic vision into a concrete engineering project. Despite the technological leaps, the path to a fully operational space shield is fraught with immense challenges. The sheer scale of the project is daunting. Creating a constellation large enough to provide continuous global coverage requires manufacturing and launching hundreds, if not thousands, of satellites, an unprecedented logistical undertaking. The system must work flawlessly, with every sensor, interceptor, and line of code operating in perfect sync. A single failure in the command and control chain could mean the difference between a successful intercept and a catastrophic failure. The technical hurdles, while no longer deemed impossible, remain formidable, and the first major integrated test isn't even scheduled until late 2028. Beyond the technical and financial costs, there are significant strategic risks. Critics, including many respected scientists, argue that building such a shield could be dangerously destabilizing. They fear it will trigger a new arms race, compelling adversaries like China and Russia to dramatically expand their nuclear and hypersonic arsenals to overwhelm the defense. Furthermore, the interceptor satellites themselves would become high-value targets. An adversary could develop anti-satellite weapons to blind the system or destroy the interceptors before a conflict even begins, turning space into a battlefield and creating vast fields of dangerous debris that could cripple all satellite activity for generations. These opposing viewpoints frame the central debate. Supporters argue that in a world with aggressive, technologically advanced adversaries, a purely offensive deterrent is no longer sufficient. They see a robust defense as a moral imperative, a way to protect civilian populations and reduce the chance of a nuclear exchange by making a first strike seem futile. From this perspective, the Golden Dome is not an escalation, but a necessary step to restore strategic stability and ensure the survival of the nation and its allies. They believe the risk of inaction in the face of new threats is far greater than the risk of provoking an arms race. Ultimately, the pursuit of a space-based missile defense system marks a pivotal moment in human history. It represents our attempt to impose order and security on the near celestial realm, transforming it into a shield for those below. Whether this project succeeds in making the world a safer place, or inadvertently sparks a new and more complex era of conflict, remains to be seen. But one thing is certain. As we stand here on October 10, 2025, the decisions being made today about weapons in space will define the future of international security, shaping the fate of nations and determining whether the heavens become a source of protection or the next great battleground.